when we discuss about this all below here 20 out of 25, 55 out of 60, 49 out of 60, 24 out of 25. So this is one of the way of expressing the marks. Yes or no, below here, whatever students scored.
Yes.
So this in this so we have written it in the form of something like in the top and bottom. So this top number we'll call it as, any idea below here? The top number we'll call it as
Numerator.
numerator, and bottom number we'll call it as
Denominator.
denominator. That is correct. So now any fraction it has two parts. One is the numerator and denominator.
Yes.
So now from this only we defined before, just before, fraction definition is like a part of a whole. Part of a whole. So whole is the total thing which we are talking about. That if it is an exam, the total entire marks paper is the whole. What student got is a part, that will write it in the numerator place. Whatever student scored, will write it in the numerator place, and whatever total marks of the exam, will write it in the denominator. Okay. So this is the fraction definition. So what is the fraction definition below here? Part of a
Whole.
whole. Yes, below here. So whatever part we are talking about, that will write it in the numerator place, and denominator generally will be the total or the whole part. Okay, whole parts. Okay. Yes, below here. That is correct. Now let us take one more situation. Like here we have types of, before that below here. For example, if I give you a question. Let us take suppose you are distributing 1250 rupees, 1250, 1250 rupees. If you are distributing among 25 children, okay. Or let us take 1250 chocolates. Chocolates. So 1250 chocolates you are distributing among 25 children below here. So can you tell me how many each child will get below here?
Sir, excuse me. This is Vilohit mother. Hello.
Yes.
Yeah. He's seeing his screen only. On his screen, you are scribbling. So it's very disturbing to watch him and concentrate at the same time. Concentrate on what you are writing.
Yes, ma'am. Actually, during the demo, most of the time I'll keep this screen only, ma'am, because the reason is I'll just check the student expression most of the time, how he is answering and all. So that's why.
Okay.
Only for this class, most of the time. Otherwise, I'll use this plain screen and or the side board most of the time.
Okay. So is he able to see your face and your writing and everything in normal
Yes,
face?
in the plain space, I'll write it, or else I'll do one. Just I'll open one more. Yes. And you're hearing any other voices from my side, ma'am? Here outside, some voices are there.
No, nothing. Only your voice is audible.
Okay, just a second. Okay, Vilohit. So here, the one which we were discussing just before, that is just fraction representation. Fraction representation means it will have a numerator and denominator. So now we will learn about types of fractions. Before that, Vilohit, I was asking you, suppose 1250 chocolates you are distributing among 25 children or friends. How many each person will get? 1250 chocolates if we distribute it among 25 people. Suppose.
1,250
Means to get Vilohit.
25 people. People and
Any idea which operation we should do?
division.
Yes, Vilohit, that is correct. So suppose if I divide 1250, once you'll try to tell the steps Vilohit, 25. I'll divide it. So how much will come? Or else you can do it in the book below. You can do it in the book.
Quotient is 5.
Okay, Vilohit. So Vilohit, here students will do one common mistake. So once see Vilohit, I think one show me the division.
Dividend. Dividend.
One show me the division. One show me the division here, Vilohit. Understand?
What about the zero number?
Okay, Vilohit. So Vilohit, once see 25 into 5 you took it because the reason is first two digits is smaller than 25. You took 20, you have counted 25 table and you have take 25 into 5, 125. Correct, no? Then after that you subtracted it, but division should be like in which step we should stop the division, Vilohit, after all the digits of the dividend. That is, this number is dividend actually. This number is dividend. So after once all the digits of dividend are finished, then we'll stop the division. So we have 1 0 left beside, no?
Yes.
So that 0 we should bring down as per the procedure. We should bring that down in the next step. That is after subtracting the first, in the first step after subtraction is finished, that 0 will come down. So now this 0 we have to divide it because this is part of the dividend. Okay, dividend completely has to be divided, even whether it is the digit is 0 or anything. Once it is brought down means we have to divide it, but here the number is 0. 0 is smaller than the divisor 25.
Yes.
So in that case, but still that has to be divided because it's part of the dividend. So 0 times 25 into 0. Why? Because 25 into 1 is 25, which is more than 0. So I have to take 25 into 0 times. Okay. So finally, I have to stop it here because there are no digits of the dividend to bring down. Okay. So answer is 50. Push. So one more division we have, Vilohit here. Actually here is Vilohit. So finally, each person, each student will get 50 chocolates if you distribute 1250 among 25 people.
Okay.
Okay. So one more division I am giving Vilohit. 6350 divided by 7.
Hmm?
So Vilohit,
The quotient is 97.
97.
Remind.
Remainder is 1.
Okay, Vilohit. Here also, once show me the division, Vilohit. I know there is one common mistake students will do.
907 Ravali.
Okay, Vilohit. So Vilohit, once see, like in every step after subtraction, we can bring how many digits down?
Sir?
In every step in division, we can bring just only one digit down, no?
Yes.
Digit by digit. So first step actually 63. So we can take two digits because in the starting step you can take two digits as first digit is smaller than 7. If you keep 0 times also not a problem, but you can take 63, no problem. Directly 63 into consideration. In the first step only, this we can do it only in the first step. Because divisor, even though actual process is what, actual process, if divisor is single digit, you have to go with single digit only in the dividend also. But first digit 6 is smaller than 7, so you have to take 0 times if we go according to the actual process. But since anyway 6 only will come here, teachers will ask directly to take 63. Because in the starting step, if you write in the starting, if you don't write also not a problem, because if I write 0, 1, 2 or 0, 0 is there in the starting place means this still is read as 12 only. Yes or no? 0, 1, 2 or 12, both are same, no?
Yes.
Lohit? So because of that reason, teachers will ask you to take here directly 63, even though if you don't take 7 into 0 times, not a problem. But this will be repeated in the next step. Students will continue doing that. So here, suppose you might have done 63, you considered and you took 7 nines, suppose 7 nines, 63. Then you subtracted it, 3 minus 3 is 0, 6 minus 6 0. Then as per the procedure, you can bring only one digit down.
Yes.
2 digits we cannot break. So 1 digit down. So this whatever digit we brought down, here means we got zeros. Otherwise, suppose here 1 instead of 0, 1 is there means Vilohit you would have divided. No, 7 2s are 14 you would have taken. Suppose this is 1, this is 1 suppose. Then 15 nearest number 7 2s are 14 you would have taken 100%.
Yes.
But since that you got 0, then you didn't understand suddenly. Means you confused and took entire 50 at a time and 7 7s are 49. Okay, but as per the procedure, we cannot bring the second digit down direct. Whatever digit you brought down, that is 5, this number, whether it is smaller than 7 or bigger than 7, you have to divide it, like in the before division I explained. In the before division, 1250, 25 times 1, 125, 0. Once see the screen below it. Then 0, you brought it down. Like I said, whatever you brought it, that has to be divided, whether it is smaller than 25 or bigger than 25. So 25 0, 0 I took it. Similarly, this 5, whatever we brought down, the number here is 5 now. 5, you have to divide it. You cannot bring the second 0 down. Okay? The other 0 down in this step itself. So then 5 is smaller than 7. What we should do? 7 table, if you count it, 7 ones are 7. Starting number itself is 7. Yes, no?
Yes.
How many times I should take now? But because you have to divide that 5. Without dividing, we cannot bring 0 down.
Yes.
So how many times I can take Vilohit like I did here?
0. 0 times.
Vilohit. 7 zeros are 0. Or some teachers directly they'll keep 0 there and then they'll bring the 0 down in this step. Maybe you might have noticed it that way. Okay, but actually this will not confuse you. In every step, whatever digit you brought down, just we have to divide it. So 7 zeros are 0, then 5 will come down. Then this 0 we can. Now it will become. Okay, so 7 14. Now like you said, 7 sevens are 49. Then what is the mistake? Mistake is below hit 97 907. There's a lot of difference, no?
Yes.
So like that. So below hit you will remember, no, this common mistake in division.
Yes.
Okay, Willow. So I'm giving one more similar to this below hit. Once we'll try to do this. 5710 divided by 19. Rohit, finished? Okay, that is correct, Vilohit. But that 0 you brought down. So 0 once it is brought down, Vilohit, that became how much?
10.
So since you brought down 0, once the digit is brought down, that has to be divided. In the next step, it will finish. The division will end in the next step. Okay, because you kept the 0 in the quotient, because when you brought 1 down, you kept 0 because 1 is smaller than 19. You have to divide it, so you kept 0. Then again after subtraction, you got 1, and then you brought the second digit down, 0. Now this part of the dividend, no, this 0 is part of the dividend. So we have to divide it now. We have to divide it. So again 10 is smaller than
19.
19. So one more 0 times. Okay. Now final remainder anyway still will be 10 only. Then what is the difference? Difference is the quotient. You will get 30 instead of 300. So forget that. Remainder we will get 10 only. Understood, Vilohit? So 330 again lot of difference. So because of that, so this is one of the example where remainder will still same. It will be same Vilohit, but quotient will get the difference. So once again I'll explain this Vilohit. 5710 when you are dividing with the 19, 19 3 is a 57. This got divided, and then you brought one down. So one is we have to divide each and every digit. That is entire dividend. So one you brought down. So one this number is 1 is smaller than 19. So you took 0 times, and then we will bring the next digit down. This 0 is part of the dividend. So whatever number is there here, that has to be divided. Like, sorry, we have to divide that. Because the reason is this 0 is part of the dividend. The number formed here is 10. 19 zeros. So in one more step, the division will finish. Here, sorry, 10. Remainder is 10. Then how can we understand whether we should stop it here or here? So we should stop in the place where we are like, is there any digit to bring down here below it?
No.
So we should stop it here, but not in the before step. Okay. Okay, Vilohit. Now once quickly similar one I am giving Vilohit. Once you can do this. Divided by 200.
పెద్దగా కనిపించలేదు screen. అట్లా కొట్టేస్తాను. అంతేనన్నా 10 ఇంక లేదు కదా దించడానికి. నో నెంబర్ నా 2000 correct only na. Remainder is 3. That's it. Got it?
Vilohit, punch show Vilohit. Okay, Vilohit. Okay, that is correct. So 3 is smaller than 200. So 200 0 times we took it. No. So division ends because there is no digit to bring down. That is correct. So Vilohit, you know tables till which number perfectly?
Till 10th table.
Till 10 table.
Yes.
Okay, Vilohit. Once you tell quickly 9 table, Vilohit.
1 9s are 1, 9. 2 9s are 18. 3 9s are 27. 4 9s are 38.
Okay.
I mean, sorry, 36.
You have learned it like this, 9 into 1, 9 into 2, like that also you can tell, or this way only. That is also okay, or this way. This also okay, not a problem, but anyways, okay. Means 9 into 1, 9 into 2, 9 into 3, like that also you can tell, Rohit, or only this way.
Sir,
Okay,
No.
Rohit, no problem. You can tell. You can tell.
9s are 9 or 9 ones are 9? Which one you learned? 1 9s are 9, no?
1 9 9.
1 9 that method
Okay.
is.
Suppose if I ask you 9 into 5 directly, can you tell?
Yes, sir. 45.
Okay, Rohit. 9 into 8,
72.
9 into 6.
Into 6.
Okay, Vilohit, no problem. Actually, Vilohit, if you said 9 into 5, 45, no?
Yes, sir.
So, since it is 9 table, add 9 to that. Suppose suddenly if you didn't get anything, if it is 9 table, just add whatever the before number, if you know, quickly you can add 9 to that. 45 plus 9,
54.
54. Suppose, but for this you need to know the before one correctly. 9 into 5, if you know 100% 45 is correct, then this will work. Suppose if you suddenly forget 9 into 6. Okay. So if it is 8 table, you have to, suppose if you know 8 into 5, 40, and 8 into 6 you forgot. But 8 into 5, 40, you should know 100% that it's correct to apply this one. So since it is 8 table, 8 only will get added to the next one. So 40 plus 8, 48, like that. Suppose 8 into 7 you forgot suddenly. Then what you should do, simply 48 plus 8 you should do, 56. If you forget this, okay. But most of the time we should perfectly remember till 10 table minimum, means minimum. This is minimum means why minimum? Because Vilohit, if you suppose if you don't know 12 table also, not a problem. Why? Because if you know till 10, all the digits we have are in math system 0 to 9 only. So if you know till 10 perfectly, you can tell any table, because suddenly if you know 15 into 8, if you want, means 8 into 5. So here what which table is required for us? 8 table is required. 8 5 is 40. It was 8 plus 4 12. Like that normal multiplication we can do it and we can tell. But so because of that reason, till one digit, like till 10 table perfectly, like you said, that till 10 table if you know perfectly also, not a problem. But with time, to save the time in exams, will okay, slowly daily, like weekly 2 tables extra if you learn also. In 1 week you can learn, sorry, in 1 month you can learn till 15 tables. Okay, till 15. Slowly we can learn till 20. So in 7th class, but as of now we will just keep 15 till 15 as a target here in next 2 months. Okay. So if you learn till 15 table, it will be advantage for us perfect, to save little amount of time. Otherwise, till 10, if you know perfectly also, you can, suppose if you require anywhere 15 into 8 means we can do normally there only multiplication. You can tell the answer. You can get the answer. And one more thing, that students are doing a lot of mistakes with subtractions as well. Like common mistakes in division, subtractions also. Let us check with some subtractions. Suppose this one will only.
Okay.
Once you subtract these numbers below it, 14097 minus 765488.
నీట్గా ఈ నెంబర్స్ 9 రాలేదు. 9 is like a 0. This one.
So done.
Yes, Rohit. What is the answer, Rohit? Okay. Just a second, Rohit. Once you'll tell the digits, sir.
Answer is 234498.
Okay, we'll have it once and check. Okay. So, Rohit, once you will show me that once I'll check the borrowing. Or else, if possible, you can send the picture also, no problem.
చీకటి రావాలి.
So there isn't.
Okay, Rohit. So here also we look it in the subtraction also only in one like most of the time because of one digit only one digit students will make mistake. What is that once I'm checking? Just I'll explain once. Okay. So we look it once see we look it. First here in the first step you started the subtraction with the ones digit. So 7 is smaller than 9, you took borrowing, no?
Yes, sir.
So from which number we took borrowing?
From 9.
9. So 9 will become immediately how much below here?
8.
8. Now 7 took 1 from, so this will become 17. 17 minus 9 is correct below.
8.
8. You wrote correct. Now below here, next place, tens place digits when you are subtracting. 9, 8, in the place of 9, now it is 8. 8 minus 9 we cannot do again. Yes, no?
Yes.
So we have to take borrowing. Yes or no?
Yes.
From where we will take?
0.
But 0 can it give below here? Because 0 means it has no value.
Yes, sir.
Okay, let us think. Let us think. 0 can give also, but how much? 1 can it give 1?
No,
Because
sir.
it has 0 actually. Before means your 9 is there. From that we are taking 1, so it became 8. But 0 means we cannot take.
Yes, sir.
No? So here this 0 actually will take from before 1 again. But before 1 also it's 0.
Yes, sir.
So
So
this also 0, this 0, this 0, all that. Just a second below it. Or it's okay, we'll continue. Yes, Mira. So here 17, now this 8 actually cannot take from 0 because its value is 0, that's right.
yeah.
If suppose this should give it to this means this should take from the before one. But before one also is 0. That before also is 0. That before also is 0. Then borrowing will come from where? This
1.
this one will give it to the other ones, then the other one will give it to the other.
Yes, sir.
Like that it will happen here. So now this one will become 0 and it will make this one 10 first.
Hmm.
This one it will make 10 first.
Yes.
Okay. So when it becomes 10, this immediately now imagine here, this will give it to the beside one and this will become 9.
9.
Now again this will become 10 and this will give it to the next digit. Then immediately this will become 9.
9.
Similarly, it will continue like that. Then this will become 10 now, and this will give it to the other one. This will immediately become 9.
Hmm.
Now this is 10. This is 10 now. This will be give it to 8, and this immediately will become 9. Okay. So here you thought that this 0 only will give it to that. So you wrote by mistake there 8 below it. That's why 8 minus 4 Remaining all digits again it came correct. Okay, so this one is actually giving to these, and finally all those zeros are becoming 9 and this one is becoming 0, whereas that 8 will become 18. This 8 is becoming 18 because this is 10 before actually. This only gave it to them. Okay. Any doubt below here?
No, sir.
Yes, below it. So now 18, that is actually 18 minus 9 is
9.
9. This also I think you did correct only. The before one went mistake. The
Yes, sir.
before one you thought that 9 will become 8.
Yes,
But
sir.
actually this one is the transfer is taken from this one actually. So slowly all those will become 9s and this is. So this is how much below it now? 9 minus 4?
5.
5. Then 9 minus 5? 4. I think remaining all digits they're correct.
Yes, sir.
Yes, 3. So the where zeros are there, we learn it in exam also. In first chapter especially, that is knowing our numbers. First chapter we have all division, multiplication, addition, subtraction. Okay. And in combination questions, combination means in some questions we need to do like addition, subtraction, or subtraction, multiplication like that below it. So you need to be very careful because the reason is suppose if it is a 3-marker question, if it is a 3-marker question, if any of the digit goes wrong also, automatically because of this what will happen is in that suppose imagine in that question you need to do one subtraction and one multiplication. Let us imagine as per that word problem it is for 3 marks, and because of this one digit what will happen next with this answer you need to do multiplication next in the next step. So automatically because of this one digit multiplication also will go wrong.
Yes.
So because of that, teachers are not even giving mark complete 3 marks. They are removing that because or half mark there just because you know that procedure of doing multiplication addition in that sum. They're just giving half mark or 1 mark as per their wish. But sometimes some teachers are completely removing.
Yes, sir.
So here the point is, Vilohit, suppose you after reading already we know that in your school exams they'll frame a new question. So you have to understand that and you have to. So once after understanding, you know that you have to do multiplication, subtraction, and multiplication. All that will become waste. Means your understanding thing will become waste if you do this mistake.
Yes, sir.
Means because you're going to lose 3 marks even after knowing that you have to do multiplication and subtraction. That question. Some students will not do that also. Some students will not know what to do in that sum also. Because of just calculation mistake, 3 marks will go here. Okay.
Hmm.
So we should be very careful, especially when you are doing subtraction and division. In addition, multiplication, most of the time students are doing correct in addition and multiplication. In subtraction and division only, mistakes are going below it.
Yes, sir.
Okay. Yes, below. So we'll do one more subtraction. Just I'm giving one more subtraction. This one will only 29337 minus 22665.
Done, sir.
Just a second. 6672. Will you hit?
Yes, sir.
Okay, one second. Okay, will you hit? Correct. 6 13 minus 6. This will become 12. 12 minus 6. Sir. So then this is 8. No, will you hit?
Yes, sir.
Okay, Vilohit. So Vilohit, you can be careful when zeros are there, especially the number when you're doing subtraction. First zero will become 9 only. Okay, next zeros also will become most of the time 9 only, unless we have down also 0. Suppose means down also 0 means sometimes if 0 requires no borrowing, if suppose from that we didn't take anything, or like down 0 is only there, 0 minus 0 0. Okay, Vilohit. So now Vilohit, like I will go to that fractions part. Actually, if you remember, Vilohit, the decimal 1 by 10, 1 by 10 is read as
0.1.
S, Vilohit, 0.1 means how to read 1 by 10, Vilohit. 1 by 10 is nothing but 1/10, like that. We will read something, no? Like for example, let us take, means how to read it as 1 by 10. How to read it as 1/10, 1, or simply 10th only. 10th only. 10th also you can take, because if you remember, Vilohit, let us take 252 259.158 below, or 1172. Let us take. So expanded, there is one thing called expanded form of expanded form. So what is expanded form, Vilohit? Once you will try to remember in 200 plus something like that will be there. You remember place values.
Yes, sir.
So this 9 is in which place, Vilohit?
Once.
9 is in
Once.
5.
Tens.
Yes, Vilohit. 2 is in hundreds place. Like that, decimal also will have its own place value.
Yes, sir.
So what is the place value of the decimal first digit after the decimal?
1 by 100.
Okay, this position is actually called, like how we will call this as ones, tens, hundreds below. If this first place after the decimal we call 10, T and TH. Means generally before decimal, whatever number is there below, that is called as whole part. This 257 is called as
Whole part.
whole part, and after decimal, whatever it is there, that is the decimal part actually. Okay, below.
Yes, sir.
So decimal part, whole part. So in the in the whole part, the digits place values actually they'll end with the letter S below, like ones, tens, hundreds, thousands, like they'll end with S. In the decimal part, it will end with TH, like first here there is no 1th position, directly it will start with 10th position. 10th means the first digit after the decimal is the 10th position.
Yes, sir.
Okay, T and H, like that next digit 7 is in 100th, DRE
T.
T 100th position, and 2 is in the 1000th, like that it will go. So here what is the expanded form of this is 200 plus 2 is here whole part, 2 is in the 100s place, so 100, 2 into 100, 200 plus 5 is in the 10s place 50, 5 into 10, 7 is in the 1s place 7 plus 7 into 1, 7. Now 1 is in the 10th place, so 1 into 1 by 10, it will become 1 by 10. Means whatever digit is there, that by 10 we should write.
Yes, sir.
10th, 1/10 we'll call that. 1/10 plus 200th, sorry, 700th means 7 by
100.
100 plus 2000th, 2000.
2 by
So 2
1000.
by 1000, like that. This is so 1 by 10. Actually, the decimal is how much below here? Like you said before,
0.1.
0.1. 7 by 100,
0.01.
0.07,
1. 7. 7. Sorry.
and 2 by 1000 is
0.002.
yes below here. So these decimals, if we add it along with the whole part, we'll get that number again.
Yes, sir.
So what we can understand from this, any number is actually formed by adding the place values of individual digits present in the number. Means expanded form is nothing but place value of each digit present in the number. When you add those, again number is only formed.
Okay, sir.
So yes, below. So how to add these now? How to add these is below it. We have to means whole part and decimal parts. We have to write it clearly. To suppose if you are adding back and getting, if we get back the number 257, 59.172, we have to add in this way below it. 200 is a whole part. Actually, 200 has no decimal. So if you want, you can keep some zeros. Why I'm keeping 3 zeros? Because the highest number of decimal places is 3.
1000.
That's right. So that now next number is 50. I have to mark it in the ones and tens place. Remaining place is 0. Then again 7 is in the ones place because it's only one digit. Again I'm keeping zeros. Then 0.1. 1 by 10 means 0.1. If you want, we can make them zeros. Because after one, if you add any zeros also, it's still 0.1. Okay, Vilohi?
Yes, sir.
So 0 point now this 0.07 now. 0.7. If you want, you can make it 0. We can write one more 0 there. Then third digit is 0.002. So Vilohit, this adding 0, if you see this fourth number, I kept 2 zeros after 1. No?
Yes, sir.
Actually, it is 0.1.
Mm.
But I kept 2 zeros after 1. Why I kept this? The reason is if I keep any zeros there, any number of zeros, its value is still same. But why I kept 2 zeros is I just want to match it with the highest number of decimals here.
Yes, sir.
This matching, we are doing it. This thing is nothing but like decimals. Means while adding or subtracting, suppose if required, we will add some zeros after the digits to make them equal to the number of digits, highest number of decimal digits in any of the number.
Yes, sir.
Okay, this thing is called as like
Decimals.
decimals. So, for example, whole part, if you want whole part also, you can keep zeros. Whole part, if you don't keep also, not a problem. But what are like decimals below here? Like decimals means you have the same number of decimal digits. After the decimal, if you have the same number of decimal digits, like two decimals, 3 decimals, 4 decimals, like the same of them is, those are like decimals. So, if suppose the decimals are unlike, also still you can make them like decimals. Okay, Vinod?
Yes,
For
sir.
example, let us write, so if we'll add these now, we'll add this. So if it is a whole part, you can add zeros before. But if it's a decimal part, after we can add, but in between we cannot.
Okay, sir.
Okay. So we will add these all zeros plus 2, only 1, 2 is there. So I'll add that. I'll just 2. Then here nothing, here 1, 7 is there. That only will come. And here 1, 1 is there. So 172 came now, Vilohit.
Into decimal.
So then finally here 7 and 0, so all 7 and 1 5 is there. So simply if you add all the place values of individual digits present in the number, you will get the number only.
Yes, sir.
So this is about the expanded form and like decimals below. Like let us take what are unlike decimals then. Like decimal, unlike decimals are the decimals whose decimal digits suppose we have different number of decimal digits. Like for example, let us take this one. 0 0.1, 0 0.1, 0 0.07, or 0.002. Let us take this. So if you see this has 3 decimal digits because these zeros have to be counted because they are there before the digit 2.
Yes, sir.
If they are suppose after 2 means we need not count them, but before digit 2 is there, so these have value. So that's why this has 3 decimal digits.
Yes, sir.
Then 0.07 has actually 2 decimal digits. After decimal, we have 2 digits, 0 and 7. 0.1 has 1 decimal. So like this, if we have different number of decimal digits, we need not check the whole part. Whole part, if they have same number of digits or different number of digits, also not a problem. Means like here all zeros are only there. Like one might have 1, 12, 15, 159. Like the different number of digits, if they are there, also not a problem. Okay, but decimal, if we are talking about like or unlike decimals means irrespective of the whole part. Before decimal, whatever it is, whether they are the same number of digits or different, also not a problem. But if the decimal number of digits are different, they are unlike. Means number of digits 3, 2, 1. They are unlike. Same number of digits means like. Okay, Rohit. In fractions also we have this like fractions, unlike fractions. Okay. So here for adding and subtracting, this is important for us. Without confusion, we can do. So these are actually unlike decimals. I can make them like by just placing zeros after the digit, but not before 1 or something. Here after 7.
Yes, sir.
Okay. I made it like decimal by writing three decimal places without changing the original value. Is it okay, Vilohit?
Yes, sir.
It's Vilohit. So this is about the like and unlike decimals. So what are like and unlike decimals, Vilohit?
Sir,
If you have, yes, Vilohit, you can. So yes, Vilohit. The bottom one are unlike and one's little left side. Right? This side. This side. Okay, Vilohit, that is nice. Vilohit. So Vilohit, now like in the starting I was telling fraction is defined as a part of a whole. Like I was asking about proper fraction. So we have like once we write any fraction, numerator and denominator. This top one is the numerator, no, below here.
yes, sir.
After one is denominator. So NR and DR, like I wrote small short form button. So
Yes.
numerator and denominator. If I write some more fraction like 2 by 9, 3 by 12, like that. If I write 5 by 8. So with these fractions, if you observe, in all of those numerator is smaller than the
Denominators.
denominator. So because of that reason, like if common thing for all these fractions is even though numbers and digits are different, numerator is smaller than the denominator. So proper fractions are those fractions, Vilohit, whose numerator is smaller than
No.
Vilohit?
Denominator.
Denominator. Basically, numerator less than the denominator, we'll call them as proper fractions. Okay. So now there is one more thing called improper. So improper fractions exactly opposite to that.
Numerators are bigger than the denominators.
Yes, below. Suppose if it is equal, like let us take 25 or 25. This also is considered in improper.
Improper fractions.
Means numerator and denominator, if it is equal also, is considered in improper.
Yes.
Okay, below hit. So 26 out of 25, 27 out of 25, 20 out of 25. Like that. So actually improper fractions we will see in our day-to-day life many times, but most of the time students, if it is marks related means numerator cannot be more than the denominator. If it is marks related, either numerator will be equal to the denominator or less than the denominator. So if it is normal day-to-day life situations, we'll have many improper fraction situations. Anyways, when we are doing word problems, that time I'll explain better. So now below it, this improper, what is improper fraction? Numerator is more than the denominator, or if it is numerator is equal to denominator also, it is improper fraction.
Sure.
So once you try to tell any few examples of proper and improper fractions, you know, on your own.
Improper and proper fractions, sir.
Yes, we learn proper fractions and improper.
Tell me about them. Fraction. Divisible आएगा 8/2.
Sir.
Okay, Vilapi, that is correct. So finally, there is one more. We have some different things also, but proper, improper. There is one more thing called mixed fraction and unit fractions like that will be there. But unit fractions are easy only below it. Unit fractions are nothing but. But since we just now discussed the improper, we will discuss about the mixed fractions once immediately.
Yes.
So mixed fraction actually can be written only for improper fraction. Okay. So what is this mixed fraction? So mixed fraction is a combination of whole part and a fractional part. So this fractional part 100% it will be proper fraction. Is what is that? Suppose let us take a 28/25. So like I said, numerator is always the dividend. You are dividing numerator with the denominator, the fraction. Okay? Numerator, you are dividing it with the denominator. So 28, if I divide it with 25, I have to take 28, 25 once, 20. So are there any digits to bring down below it?
Sir?
Are there any digits to bring down?
No, sir.
So the division ended there. Okay. So now this upper number we'll call it as
The
quotient.
quotient.
And the down one we'll call it as
Remainder.
this one we'll call it as
Divisor.
divisor, and this is dividend. So now Q R by D. I'll ask students to remember this way below it. Q R by D form is called as mixed fraction. Like whatever quotient we got here, that we will write it remainder by divisor. Quotient remainder by
Yes, sir.
divisor.
Yes.
Okay, we know it.
Yes.
So quotient is how much? 1.
1, 3
And
by
remainder is how much below it? 3. And divisor is
25.
20. So here if you observe, this 1 is called as the whole part below it. 3 by 25 is clearly the fractional part.
Yes, sir.
And clearly it is a proper fraction also. You can observe.
Okay, sir.
So 28 by 25 same as 1 3 by 25 below. So the mixed fraction can be written only for a proper improper fraction. Actually, improper fraction only you can write mixed fraction for only improper fraction. 28 by 25 can write it like that. But once you write 28 by 25 as a mixed fraction, in that mixed fraction we will get a whole part and a fractional part. That fractional part is 100% a proper fraction. Okay, Vilohit, what I'm trying to tell, have you understood? Okay, Vilohit. Anyways, in detail, again, we'll continue this one, Vilohit, in our next class. We'll continue this part and then unit fractions and all. And we'll directly discuss the important questions, models and all concepts and all directly since exam is about it. Okay, Vilohit.
Yes, sir.
So whatever we have discussed today, you have understood, Vilohit.
Yes, sir.
Vilohit. Vilohit.
Yes, sir.
Okay, Vilohit. So mixed fraction can be written only for what type of fractions, Vilohit? Improper fraction.
Improper.
Yes, Vilohit. When we write any improper fraction as a mixed fraction, we'll get a whole part and a fractional part, and 100% that fractional part is a proper fraction. Means, sir, we are writing the improper fraction as a mixed fraction. When we write improper as mixed, we'll get a whole part and a fractional part, but that fractional part should be proper fraction. If you get improper, means your division might have went wrong. Okay, when we are writing it like a mixed fraction, if this division will go wrong, means we'll get here improper
Yes, sir.
in the place of 3 by 10. Okay. So again, from this question, we'll do freshly in our next class. Will okay.
Yes, sir.
Okay, we'll okay. Bye, will okay.
Bye, sir.
Okay.
Hello, sir.
Amen.
అది టైమింగ్స్ ఒకసారి నాకు కన్ఫర్మ్ చేస్తారా? అంటే 6:30 to 7:30 అయితే తిని అటెండ్ అవ్వగలుగుతాడు.
నేను ఈ టైం మనకి అంటే ఈ ఒక్క వీక్ మనకి అంటే కొంచెం టైమింగ్స్ అంటే నేను ఒకసారి రేపు మీకు మళ్ళీ కాల్ చేయాలి మేము ఒకసారి
ఒకసారి చేయండి, ఎందుకంటే తను క్రికెట్కి వెళ్తాడు 4 to 6. 6:30 to 7:30 అవైలబుల్ ఉంటాడు.
మోస్ట్ ఆఫ్ ఈ మన వీక్ డేస్ టైమింగ్ 6:30 to 7:30 మోస్ట్ మేము ఈ ఎగ్జామ్ వీక్ వరకు మాత్రం ఒకసారి రేపు మీకు ఒకసారి నేను
ఓకే.
అంటే కొంచెం నేను ఎగ్జామ్ నెక్స్ట్ ఉంది కాబట్టి కొంచెం తొందరగా ఆ టాపిక్స్ కవర్ చేయడానికి.
ఓకే. ఓకే.
అవును.
ఓకే.